This conference will now be recorded.
All right, this is the Unit 4 review. I'm going to go through the ones we did not get to in class and do all of the Part Bs. So we're going to sketch the graph of the circle, then list its center and radius. So for this one, remember to get the center, you have to find the opposite of each of the x and y's. So my center here would be -6 for the x, because that's what makes this 0, and 4 for the y. This is r squared, remember, in the formula. So r squared is 9. So that means r is 3. So there's my center and my radius. So I just need to plot this. So I go 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4. Remember, we don't actually put a point here. I know he has a point on the answer key. It's technically not a point, but he was just trying to show it. It's C for center. And then we go a radius of 3 all the way around. So you go 3 to the left, 3 down, 3 to the right, and 3 up. And then you draw the best circle that you can. Of course, I'm not even using gridded paper, so it's going to look like a smushed egg. Okay. For 2, we did that one in class, so we're going to look at 3, which is sketch the graph of the ellipse, then list the center, the vertices, the co-vertices, and the foci. So the center, again, is the most important thing to start off with because you build everything off of that. So this has a center. Remember, always look for the x first. So that is centered at -4 and then +2. This one is oriented in the y direction because remember, when you're dealing with an ellipse, the bigger one is the orientation. So the bigger one is a squared. So this is a squared, this is b squared. Those can be flip-flopped on an ellipse because it's always the bigger number that's a squared. So my a would be ±5, and that has to do with my vertices. My co-vertices I'm going to find by doing square root of b squared, which is ±3. And it's important to know that this one is in the y direction and this one is in the x direction because of which variable it is underneath. So for my vertices, I'm going to add and subtract 5 to y of the center point. So that's -4 minus 5 from that would be -3. And then -4 and add 5 to that, that would be 7. The co-vertices, we're going to find those by adding and subtracting 3 to the x's from the center. So subtract 3 from -4, that'd be -7, 2, and then add 3, it'd be -1, 2. To find your foci, you have to know your c squared. So remember, the formula for the relationship with the ellipse is that c squared is a squared minus b squared. It's really easy to remember. If you have a plus here, you have a minus in this formula, so it's always opposite. So c squared is 25 minus 9, which is going to be, is that 16? Yes, so C is ±4 here. So remember, we do the same thing that we did to the vertices. So the vertices were y direction. So we're going to do ±4 in the y direction. So for my foci, go back to your center point. It's going to be -4, subtract 4 from 2 would be -2. And -4, add 4 would be 6. Okay, now we have all of our pieces. We're going to graph this out. Let me just get enough marks. Okay, so -4, +2 is the center. So I'm just going to mark that. -4, -3 is the smallest vertice. So that's V prime. -4, +7, so 3, 4, 5 is the larger of the vertice. And my co-vertice, remember we call those M prime and M. That is -7. So this is -4. So 5, 6, 7, -2. So that's going to be M prime. And -1, 2 is going to be M. My foci are -4, -2. So that's this one. And -4, +6. Notice that this is a little bit longer in the y direction than it is in the x direction. That is its orientation. And you just connect your M and V's all together. And of course, this would be better if you had gridded paper, but you get the general gist. That is an awful ellipse. Okay, so let's look at the hyperbola one. So we want to find the center, the vertices, the foci, and the asymptote. And notice this time this one leads with a y, so that means it's going to be an up-down hyperbola. If it led with an x, it would be left-right. So we at least know our orientation. And that it means that this is a squared, because in a hyperbola, a squared is always under the first one, b squared is always under the second one. When you go to find your center, you need to be more careful here because the x is actually over here. So x always goes first. So this is a 4 and then a 1. And then I'm going to be using plus or minus 3 in the y direction because it's under the y. And that's going to be for my vertices. For my other rectangle points, I'm going to be using plus or minus 4 because that's the square root of 16, and that's going to be to the x values. I need to find my foci value. So c squared is a squared plus b squared with a hyperbola. So that is 9 plus 16, which is 25. So that's going to be plus or minus 5. And that is also going to be in the same direction as the vertices. So that's going to be in the y direction. Okay, so let's find all of our points and then we'll talk about our asymptotes. So our vertices, and he doesn't ask for the rectangle points, but I always list them just because they help me graph. So for the vertices, we need to add and subtract 3 to the y value. So 4, and then that would be 1 minus 3, so that's negative 2. And 4 plus 3 to the 1 would be 4. Our rectangle points, remember these are called W prime and W, and these are V prime and V. The rectangle points are found by using the x value change. So that's going to be 0, 1, and 8, 1. The foci are going to be, remember, our F prime and our F. We have to do plus or minus 5 in the y direction. So that's going to be minus 5 would be negative 1, 1. Oh, sorry, y direction. I just said y and I did x. Sorry. So we have to do the same thing we did to the vertices. So 4 and negative 2 minus 5 would be negative 7. And 4 plus 1 plus 5 is 6. Okay, so then we need our asymptote equation. This is easy to get if you know your a and v and which one's under y, because your slope is always the one that's under y, and it's the square root of that number. So it's going to be a 3 over the 4, and it's going to be plus or minus. So remember, if you have your center point, you just use point slope formula. So y minus the y value equals plus or minus 3/4 x minus the x value for the center. So that's my equation for the asymptotes. We don't technically need that, remember, to graph. You just need it to get your point for the equation. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 4, 1 is over 4 up 1. That's my center. 4, negative 2 is my first vertex, and I did that too high. So 4, negative 2, that's vertex prime. And then 4, 4, so that's up here. That's V. 0, 1 is to help me find my rectangle. So that's going to be W prime. And technically there's not a point there, but I'm putting it there just so you can see it. And 8, 1, so that is 5, 6, 7, 8, 1 is the other W. The first thing I normally do is connect those with the rectangle. So remember, you just go through this one until you reach the highest and lowest value. You walk on over till you reach the W, and then you connect that down. That helps me draw my asymptotes because remember, they go through the diagonals and through the center. Just do the best you can when you don't have a ruler. Of course, try to make it straight, but I'm looking for the structure of what you're doing. And then my foci are 4, negative 7, so that's negative 3, 4, 5, 6, 7. So that's right there. And the other one is at 4, 6. That doesn't seem right. Did I subtract this too much? Oh, I see what I did. Okay. I have the wrong value right here. I did not look at the center point when I was doing that. I looked at this point right here. This is 1 minus 5, so that's -4. Yeah, because these foci points should be equally spaced on each side of the rectangle. There's a symmetry to it. So I knew that was immediately wrong. So 4, -4 is 2 down from this guy, and 4, 6 is 2 up from this one. So they should be equally spaced. And then remember, you just follow your asymptotes from your vertex. Okay, so we have that one, and it meets the orientation we expected. So now we're looking at problem 5. This is just, can you pick the equation out from the picture? The reason these are a little tricky is just finding the points for everything. So you need to locate your center. For this circle, this is right 1 and then down 1, 2, 3, 4, 5, 6 is the center. So this has a center of 1, -6. And then its radius from the center is 1, 2. So radius of 2. So remember, the formula for a circle is x minus h squared plus y minus k squared equals r squared. So we're plugging this stuff in. So x minus 1 squared plus y minus -6 would be plus 6 squared equals 2 squared, which is 4. So there's the equation for that one. Okay, so let's see what we need to pick out for B. This one is oriented on its side, so I already know that means that it's going to have a y squared orientation. So this is going to be the formula y minus k squared equals 4p and then x minus h. Okay, so we need to find our vertex because that's the hk. So that's the point 5 down 1, 2, 3. So the vertex is 5, -3. That's my h and k. The p-value is how much does it measure to go from the vertex to the focus. And that is based on positive or negative based on which direction it's heading. That is a -1. So p is -1. So when we plug this in, this will be y minus -3 because it's the y value. So that'd be plus 3 squared equals 4 times -1. So that's -4. And then x minus 5. Okay, so then we're going to do an ellipse. I'm going to switch gears and do some that are x-oriented because I think I've been doing everything. Yeah, everything I've done so far is sort of y-oriented. So let's try this one. Okay, so we need to find the center of this, and the easiest way to do that is kind of find the top of this egg and count down from there. So this is -1, down 1, 2, 3, 4, 5. Looks like it's right there. That's in line with that. So that's -1, -5 for my center. And I can count my A, B, and C values. I don't technically need the C values, but I can count my A and my C values just from here. So A is how far does it take to get to on the major axis, which is the longer part of your oval. So this is 1, 2, 3, 4, 5. So this has an A of 5, which means its A squared is 25. The B value is the minor axis halfway. So 1, 2, 3, it looks like. Let me double check myself. So 1, 2, 3. Yeah, it's 3 in both directions. So that's 3. So B is 3. So that means that B squared is 9. Because I'm oriented in X direction, that means that the bigger one is going under the X value. So remember, in an ellipse, it's always that the leading part is the X minus H squared plus Y minus K squared equals 1. The difference is, where do you put A squared? So if you're oriented as a side to side, you're going to put A squared under X. If you're oriented this way, you're going to put A squared under the Y. So wherever A squared goes, the other one's obviously B squared. So my center is -1, -5, so that's going to be X plus 1 squared over my A squared was 25, plus the Y minus -5 is going to be plus 5 squared over the 9 equals 1. Okay, and then the last one of the graphing type is one of the hyperbolas. Let's just do the one that we have right here. So this has a center of 1, 2, 3, 4, down 1, 2. So the center is 4, -2. We can count our A direction by going to the actual vertex. So that's 1, 2, 3. So A is 3. which means a squared is 9. You can count your c direction, and you actually do need that here because there's no way to find the b without comparing it to the c squared. So that means you're going to the foci. So I'm just going to go in the other direction so you can see how much I'm counting. So 1, 2, 3, 4, 5. So c is 5 because that's to the foci from the center, and that means that c squared is 25. We have a formula that says that in a hyperbola, c squared is a squared plus b squared. So that is 25 equals 9 plus b squared equals 16. So we now know our a squared and our b squared. Okay, so because this is in the direction of left, right, it means the x's are coming first. If you're going up, down on your hyperbola, the y's go first. So this is x minus h squared, and a squared is always the first denominator in a hyperbola, and then y minus k squared over b squared equals 1. So my formula is going to be x minus 4 squared over my a squared was the 9, minus y minus negative 2b plus 2 squared over my b squared, which was 16, equals 1. Okay, so that is those. And then I think we did one of every kind on the back except for, I think we skipped number 11 because we were running short on time. So let's do 11b. So for this one, we are trying to find the standard equation form of the ellipse that satisfies the stated conditions. They give me my two vertices, and you see that the 3 is staying constant. So this has a y change, but not an x change. So that means this vertice, this one is higher and this one is lower vertically. So they're kind of, so if you think about that, that means your vertices are going up and down. That means this is oriented this way, okay? Now, that tells me a couple things. It tells me that a squared is going under y because it's up, down, the y part. So my generic formula is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. So we know that we can find the center of this graph by adding these and cutting them in half. In other words, find the middle of these 2 points. So 3 plus 3 is 6. Cut in half will still be 3. So I'm going to take my 3, 8, and my 3, negative 10. I'm going to find the midpoint. So it's 3 plus 3 divided by 2, and then 8 plus negative 10 divided by 2. So that is going to be 3. This is negative 2 divided by 2, so that's negative 1. So that tells me my center. And I can count from there how far each thing was. So if you're at negative 1, to get up to 8, you have to see what is the difference between 8 and negative 1. Well, that is 8 minus negative 1, so that would be 9. Same thing here. Negative 10 and negative 1 are 9 away from each other. So that gives me an a value of 9 or an a squared of 81. For the information they gave you here, this is the foci. You already know your center, so you can just figure out how far is this from the center. Well, negative 1 is 7 away from the center. So this is a c value of 7. Also, negative 1 is 7 away from 6 on the number line. So my c squared is 49. I can find in an ellipse, c squared equals a squared minus b squared. So that is 49 equals 81 minus b squared. Subtract the 81, so I need to do this backwards. 81 minus 49 is 7, 11, so that is 2, that's not right, 32. Let me add those back together. Yeah, that's 32. Okay, so 32 is, and that's going to be negative when we move it over, so negative 32 equals negative b squared, so b squared equals just 32. So we know everything we need. We've got our center, we've got our a squared, and we've got our b squared. So this is x minus 3 squared over the b squared, which is 32, plus y minus the y value of the center, which is positive 1 now, because we're going to minus it, over the a squared, which was 81, equals 1. And there we go. So hopefully this helps you guys, and I will see you tomorrow.